Alright, so this is our second video. I did have to just use this second one. We don't have very much left, but I would like to make sure that we didn't go through this too fast here. Just make sure you know what you're asking, how many grams of CO2 and Fe. I kind of rushed through that a little bit, and some of you might not have been clear when I said hit the pause to do the problem. So this is actually going to lead in to the type of problem that we're going to do next time, which is given 114 grams of CO2 and excess of this, then we're going to have to ask the question, well, we got two different answers given the same amount, so we're going to put that on hold right now, but only one of those is the right answer, because if you start with the same amount, how much CO2 do I get? But anyway, hopefully you followed through, and again, no room for variation on these things, and make sure you're getting these atomic weights right with the new thing, the new periodic table that we have. Okay, so this is the third and final example. I just wanted to point out that many times the balanced chemical reaction will be provided for you, and that's the case right here. It doesn't hurt to double check, but I will try to make it clear, that write the balanced chemical equation first, so you could expect problems like that. But this one, it's already provided for you, and you could do any combination you wanted. Starting with this, how much of this you get. Starting with that, how much of that do you get? How much, if you knew you had this much product, how much of that product? And you could do so many different combinations. So it's really important that you just read the problem, and as you can see here, we're starting off with 32 grams of Na2CO3. Now, hopefully a little flag goes up and says, wow, that's only two significant figures. Even though we're going through that extra work to do those atomic weights, the final answer is only going to be able to have two significant figures. And again, start with what you have, 32 grams, Na2CO3, no shortcuts on this, okay? Don't get sloppy. Hopefully your notes have been neat all along, and we need to be able to tell what the story is. You're saying a lot here. You're talking about saying what the substance is, the amount, the units of measure that you use to get it. So just go through the motions of doing that. Now, I want you to do the atomic weight calculation. I just double-checked both of these, and these numbers are correct. So using your periodic table, what would you get doing the circle-square method? And by the way, I've had some students just do this, write the circle, write the circle, write the circle, and add up the three numbers. Others are more comfortable doing that on your calculator. At this time, I'm not going to require circle-square method, but when you get into more complex ones like that, make sure your order of operations is good, and those kinds of things. Bottom line, we are all going to agree on the exact answer for this. So hit the pause, crunch those numbers. All right, so it is 105.99 grams of Na2CO3. No discussion, all right? That is what we're doing. You followed your sig fig rules, and now it's two places to the right. So don't put that color periodic table away for doing these. We're just sort of showing you another method and getting you even better at using sig figs. Now remember, it's always 1 mole. If you've been in my classroom, there's just the 1 mole over on that wall where we're going grams to moles, which is what we're doing here, and 1 mole. Don't use the coefficients yet. That'll get you in trouble sometimes. Okay, so that one comes from the very definition. And it'll always be 1 outside of the mole-to-mole conversion. Now, over here, we're in our mole-to-mole conversions. So I have 1 mole of Na2CO3, so that's the product. This is what I'm looking for, and this is why you got to be careful. Those formulas look pretty identical. You don't want to get them flip-flopped. Up to this point, it's the sodium carbonate. This is sodium bicarbonate, which is baking soda, actually. So this is a little decomposition that baking soda can undergo and give off a little bit of CO2 gas. It's one of the reasons why it's risky to use this as an antacid, because it's usually followed by a big, huge belch. But some people will use a little spoonful of baking soda in water for an antacid. I recommend Tums, and they pay me for that. Tums, for that gentle sensation in your tummy when you have acid problems. Tums. Just got $1,000 for saying that. All right, so I didn't get anything. Teachers never get a piece of the pie there. I wish I did. Or wear like a Ford shirt or something, you know. All right, so this is the problem when I get too much time for a video. You're like, get on with it. We want to get doing our homework. All right, so I will. Obviously, you're going to do a grams to moles of the NaHCO3. Remember that hydrogen, kind of a weird one, 1.008. So your calculator will say 3 places to the right, but that's 2 to the right, that's 2 to the right, that's 2 to the right, so your final answer can only have 2 to the right. So when you're adding and subtracting, it's really about place value when you're doing significant figures. So that's why we're emphasizing this. So crunch the numbers, hit the pause first, do that one, get it perfect. That would be perfect if you had 84.01. Now remember, multiply all the numbers on the top, hit the equal key, divide by what's on the bottom. If there's a second one, hit the equal key, divide again. You got to make sure you keep dividing. This one, pretty simple, it has just the 1 number on the bottom, and 51 grams of NaHCO3, or 51 grams of baking soda. All right, so now you know how to do mass problems, and you get a chance to practice some more and submit your answers to me. Okay? All right, good luck on the assignment, and take care.